special types of quadratics or quadratic-like equations are equations that can be solved using easy quadratic ideas, but they don't look initially like they would be solved by like a quadratic. Most of these might be things like higher level powers, so for example a power of 2, and those are easily factored. Now the way you know if you have a special quadratic that can be easily factored when you don't see it as being a power of 2 is to look at your powers. So for example this problem here. Notice I go power of 4, but then I step evenly down. So I go 4, 2, and then nothing. So because of that, that actually tells me right off the bat that this here would be one of those special quadratics. And let me show you exactly how that works. The first thing we would do in solving a quadratic is standard form. So I need to move this over. So my problem becomes x to the 4th plus x squared minus 12 equals 0. So in this case, when I'm dealing with factoring, I know that I can open up my factor bubbles immediately. And if this was an x squared, we know that that would break into x and x. Well, an x to the 4th is going to break into x squared and x squared. So here, this becomes x squared and x squared. Now the other thing we know is that this back sign tells you which type of signs you have, and the front sign tells you which term is what value. And so here I have negative, which means my sign combinations have to be one positive and one negative. It's the only way to multiply to a negative. Now I need to look at factors of 12 that when combined will give me a positive 1. So if I look at my factors of 12, I have 1 and 12, I have 2 and 6, I have 3 and 4. Now this middle sign here tells you which factor has to be what sign. So my middle sign is positive. What that means is that the bigger factor has to be positive. So here, all of these, the 12, the 6, and the 4 are positive, which means the 1, 2, and 3 have to be negative. And I need to know which one of these combinations is going to give me 1. So negative 3 plus 4 is 1. That tells me this was the factor I needed to use so I can input my values. This was plus 4 minus 3. Now I'm solving, which means I have to keep going. You have to set each factor equal to 0. So I have x squared plus 4 equals 0, and we have x squared minus 3 equals 0. On my first one, I need to move the 4, so x squared is equal to negative 4. I need to take the square root of both sides, so x becomes the positive and negative of the square root of the negative 4. I need to reduce, so this negative has to pull out as the imaginary term, and then the square root of 4 is 2. So this becomes x equals plus or minus 2i. Now on the other side, I move the 3, so x squared is equal to 3. Again, take the square root, so x is equal to plus or minus the square root of 3. Since the 3 is positive, I don't have any imaginaries to pull out. Since I can't reduce it, those are my answers. So here, my solutions were that x was equal to plus or minus 2i and plus or minus the square root of 3. Now this should make sense because I started with power of 4. So that tells you we need to have 4 solutions. If you look here, I have 1, 2, 3, 4, so I'm done. Now the other special quadratic that we have is when we have these binomials. So if you look, these two binomials are exactly identical, the same. Only one of them is squared. So what we can do is we can do what's called u-substitution in order to solve that quadratic. So u-substitution says you are going to let u equal the stuff in your binomial. So we would say y minus 4. We are then going to rewrite our equation using the u value. So our equation is going to become 2u squared plus 5u minus 3 equals 0. We need to now solve this equation. So we can solve it using any factor method possible. In this case, if you want to do it quickly, we can use the normal factor method. So I have 2u squared, which is going to break into a 2u and a u. Now the other thing I know is that I have a negative value here and I've got this 3. Well, the only factors of 3 that I have are going to be 1 and 3. That's it. I don't have anything else to work with. And I need to come up with a positive 5 in the middle. So that being the case, using FOIL, I know that I have to have 2 times something and then something times u to give me 5. Well, if I do 2 times 3, which is 6, minus 1, I get my 5. So I'm going to put my 3 here, my 1 here, and I just said that the 3 had to be positive and the 1 had to be negative. So that is a quick and dirty factoring your square root. Okay. Now once you get it factored, you need to solve. So again, I have that 2u minus 1 equals 0 and u plus 3 equals 0. Solve each of them. For my first one, I get that u equals 1/2, and for my second, I get that u equals negative 3. Once you solve, you need to double check. Here we solve for the u variable, but my original problem had y. And the biggest thing that you have to remember is that back in the beginning we did this let statement. Once you do it once, you have to undo it at the end. So here we have to recall that we let u equal y minus 4. So we need to use that idea to reduce or reverse itself. In this case, we know that I have u is 1/2, so I know that 1/2 has to equal y minus 4. I also have that u is negative 3, so I know that negative 3 has to equal y minus 4. In both of these, I have to move the 4. So I'm going to take it and I'm going to shift it. Because it's negative, to move says add. So I'm going to have 4 plus 1/2 is equal to y. When I combine my fractions, we get that 9/2 is equal to y. On the other side, again, we still have to move the 4. So this is going to be 4 minus 3 equals y. So 1 equals y. And these were the results that I was looking for. Now, notice I used my fraction and it was a reduced fraction. The biggest thing that I can caution any and all students: never give an instructor a decimal unless you are told to give a decimal. So in these types of problems, 90% of the time, we are looking for your reduced fraction or reduced radical answer. So if you have any questions, please let me know. If you feel like you need to see additional examples or are just totally confused, please let me know that too, and I'd be more than willing to make another video chock full of special quadratic examples. Otherwise, I hope you enjoyed, and I look forward to seeing you next time.